Okay, so you guys had a chance to look at this data in terms of trying to make a model to predict the future, or I guess they've already happened, the 2012 and 2016 results for the men's long jump. So when you looked at the scatter plot for all of them, what up, Guillermo? My guy. Now, when you look at that, it's totally okay to use all of the data points. That's fine, okay? When you look at that, anyone see anything interesting happening in this scatter plot? Yes, Leslie A.
Possible outliers?
Possible outliers. Can you give us one?
Well, there's,
I think maybe this one might be. This one here.
yeah.
And maybe even that one up there. Those two? I don't know, right? I haven't calculated. All right. But if you use the internet to see more information about this one up here in 1968, did anyone do that? Why don't you Google 1968 men's long jump Olympics, see what comes up. Something interesting is happening in 1968.
Mayo.
1968.
Bob Beeman. This guy's name.
Great, thanks. Where was the Summer Olympics held?
Mexico City.
Mexico City. Do you know anything about Mexico City?
Not
Altitude. All right. So this jump, for me, I would have thrown it out because of that high altitude. He was able to jump farther than probably he would have been able to at a normal or average altitude. Okay? If you didn't throw it out, it's okay. Don't worry about it. It's all good. Okay? Did anyone else do anything else different when they did their model? What years did you use your F? Did you use all of them? Okay, who didn't use all of them? Okay, David, which ones did you use? So you did 80 until the most recent one, 2004. Why did you pick that? Because let's see where 80 is. Wow, that's really nice. Who cares about the past? So there's 80, okay? So you're using the last ones there? Like the last, what is that? 7 of them? 1, 2, 3, 4, 5, 6, 7 of them. Okay. Anyone else use any different? That's it. David's the only one that didn't use all of them. Oh my gosh, guys. I would definitely have not used all of them because look what happened between 1936 and 1948. Leap year? No, we had World War II. And the Olympics were not held. All right? So personally, the way that I did it was I made a model where I started in 1948 after World War II, and I threw out 1968. Those are the ones that I did. The World War II? Yeah, it's just a minor war.
We're supposed to know all this?
Minor.
You're supposed to know that World War II happened? Yeah, you should know when World War II happened.
I'm talking about like all when if something happened in 19...
Do you have the internet and your computer? You do, Catherine with a K, which means you could Google.
So I was supposed to Google all of them?
I think I just said Google. I Googled 1968. What happened in 1968?
Yeah, but why 1948? What if
Because
you
it
had
was really high,
Oh, okay.
right?
It was.
And then you might have Googled, why weren't the Olympics held in 1940? Nazis? No? You don't remember those guys?
It's called the Nazi Games.
I don't think they did. All right, so let's go ahead and let's show how to make the model then. If we're going to use all of them, that's fine. So we have y sub 1. Let's make sure mine's y sub 1. Yes. All right. Remember to use your approximate. What is it? What do I press? Tell me. Excellent. Is it that one? Let's shift it. Got it. Thank you. Appreciate it. And then my preference is to do the y-intercept and then the slope. But if you did mx plus b, that's fine too. It doesn't matter. So I'm going to do b plus mx sub 1. And there's the model that you guys made. Since you guys used all the points, most of you did. Sorry, David. Okay. So let's write that down. All right. So the model, if I'm going to answer number 1, is going to be Distance, hat. Don't forget your hat. If you forgot your hat, put the hat on. Okay. Equals our y-intercept for me is going to be negative 944.207. Plus my slope of 0.644 times year. So David, obviously you would have a different model. And again, if you wrote equals 0.644 year minus 944.207, that's also okay. Totally fine. Now, I didn't ask any questions like interpret the slope, interpret the y-intercept, okay? My next question was, okay, if you have this model, what's it going to look like in 2012 and 2016? So, in 2012, we're going to type in to Desmos negative 944.207 plus 0.644282 times 2012. So what are we predicting that the person, the man who won the long jump, got the gold medal in 2012, what was their long jump in inches? 352.09 or 0.1. So 352.1 inches. That's for 2012. Okay, let's do the same thing for 2016. Okay, wait for it, man. So I'm just going to scroll back over and change that to 2016. And get 354.67. David, do you happen to have yours? Your predictions?
Oh, in 2012 is 337.886.
Okay, I'm going to write yours down. You said 337.886. So 9?
Yeah.
Okay, and what about for 2016?
337.8.
Oh, so very similar. Okay. Do you want to know the what?
That's not similar.
That's not similar.
Similar to each other.
337.9 and 337.8 sure look similar to me. It's all good. I wasn't saying they're similar to ours. His are much lower than ours, right? So let's actually look to see what the long jump distance was. You ready? The real distance in 2012 was 327.2 inches. So David's was a better predictor. All right, let's go with the next one. 2016, 329.9 inches. So David's was better on that one too. All right, why do you think ours was not as good as David's? Because we used all the data. You're exactly right. Right? We would want to throw out some of these points. Probably us not throwing out what was the guy's name? Bob in Mexico City?
Yeah.
The Mexico City jump, right? I think it was Bob.
Yeah, wow.
That jump in Mexico City of being so high probably caused our prediction to go a little higher. Yes, Leslie, yeah. The real one, here's the real 2012. I Googled it. Catherine with the game. I Googled it and found the actual answers. Okay? Now, there was one more question that you needed to answer, whether you used all the numbers or not. Is your model appropriate? How do I make sure that my model is appropriate to use? Check the residuals. So remember, there's that plot residuals. You might not see it, all right, because they're down near 0. Is there a magnifying glass? Oh, it does both now because it added it up there. Sick. You guys are amazing. But I really just want to zoom in on that one. Okay? So when you look at this, what do you think? Let's do this. Maybe this will help if I take that off. Does it change it? Yeah. There we go. You think a cloud, Jarvis?
I think there's small patterns.
Okay, we're talking about overall pattern here, Catherine. Oh my gosh, that dinosaur in the cloud. No, you guys don't see the shapes, the animals in the clouds? You guys look at the clouds anymore?
Yeah.
Yeah.
Not a real one.
So if you think, If you think there's no pattern, it's a cloud, then your model is appropriate. David, what did yours look like?
A line.
Ooh, a line. So yours would have been not appropriate then, even though your model was better.
Bad model.
Dang.
Now, what was our R squared value? About 81%, and our R is 0.9. So let's say it's like strong and a good model, all right? But it's not everything that determines how far these athletes were actually able to jump, right? There's other stuff that could have determined it. So, going forward, how do we feel about linear regression? Because we're going to start reviewing for a test. What's something you're concerned about going forward?